So welcome to another segment of my mathematics videos as we continue looking at vector geometry. But I want to show you a concept that you're going to find in paper 1 of your ECZ exams. Now, like I said, a vector is simply a quantity that has got both magnitude and direction. It would do you well if you can actually go through my previous videos on vector geometry, my introduction, then you can come back to this video. It is going to help you. Now, mostly in your paper 1, they're going to be telling you about finding what we are calling as being the magnitude. So they are going to ask you to find the magnitude of a directed line segment. Yeah, so the magnitude of a directed line segment. What do I mean? Well, there are two situations that you can have when they tell you to find the magnitude or the size of a directed line segment. In the first situation, you can be given, if you're just given 1 point, so they can just give you one particular point and they can tell you to find the magnitude. For example, let me say you have the vector b, and this vector b is represented by the coordinates. Let me say it is represented by the vector. In this case, let me say -3, 4. So remember, vectors are always written in column form, but when you write, -3, 4, this becomes a coordinate. But when you write it in column form, that is simply a vector. So you need to remember that there's a difference when you write it in horizontal form. Remember, you have got x and y. If you write x and y, that's coordinate. But if you were to translate this and write it in column form, then this becomes a vector. So this is a vector, but this is referring to coordinates. So that is what you need to remember. So you can change coordinates to vectors and you can change vectors to coordinates, vice versa. So this can be changed to that and this can be changed to that. Now, for example, like I've given you, the first concept, I already have given you that. But if they have only given you, for example, x, y, they have only given you one coordinate, which we can also write in vector form as x, y. We can find the magnitude. If this was representing, for example, vector a is equal to that, then we can write the magnitude. We use the modulus symbol, where we put up these vertical lines in between the vector. So the vector A, because you're using only one coordinate, so you're just going to say the x value squared plus the y value squared, but you need to find the square root of that. So that is basically the way you can do it. For example, if I'm to find, they tell me to say find, in this case, the magnitude of B. They are going to write it in that way. How do I go about it? So because the vector b has the vector b is in the form -3, 4 in column form. Remember, this -3 is representing the value of x and that 4 is representing the value of y. So you can simply say the magnitude of the vector is going to be the value of x squared plus the value of y squared. Then you just find the square root of that. So this is going to be, what is my x? -3 raised to the power 2 raised to the power 2 plus what's y? It is 4 raised to the power 2. Whatever you get, you need to square root it. Therefore, -3 squared will give you a +9 and 4 squared will give you a 16. Therefore, what is 9 plus 16? It is simply a 25. So we are finding the square root of 25. What's the square root of 25? It is simply 5 units. So therefore, the magnitude of B is simply 5. You can add the word units. So that's the magnitude, the size of the directed line segment. So this is when you have been given 1 point. So when you have 1 point, you just use that. But suppose you have been given 2 points. Let's look at the second situation that you are going to find. So in the second situation, you may be given 2 points. So finding the magnitude of a directed line segment, but imagine you have been given point A. Let's say point A is x1, let's say that is x1, y1. And let's say you have also been given point B, which is x2, y2. You can be told to find they can tell you to find the magnitude of the vector AB. So how can you go about that? Well, when you have been taught to find the magnitude of the point from A to B, we use the distance formula under coordinate geometry. So it is x2 minus x1. Whatever you have, you raise it to the power 2 plus y2 minus y1 and everything raised to the power 2. But all this, you're supposed to find the square root of that. So that's the formula that we use. We use the distance, formula and our coordinate geometry in order to find the magnitude of such a directed line segment. Let me give you an example. Imagine that they have given you the point A. Let's say it is negative 3,3, and let's say they have given you the point B, which is maybe 5,9, and they simply tell you to say find the magnitude of the vector A, B there. So how can you go about that? Well, it's very simple. So you can say the magnitude, remember, represented by the modulus, these two lines that you are seeing, the vertical lines that you are seeing between the vector, is going to be equal to, so we apply that formula. So you can quickly label which one you want. For example, let me say these are 2's x2, y2, then this will be x1, y1. Okay, so it doesn't matter. You can call this x2, y2, this x1, y1. It doesn't matter. It's up to you which one you want. So replacing in the formula, what is my x2? My x2. So let me just rewrite the formula x2 minus x1. Everything raised to the power 2 plus y2 minus y1. Everything raised to the power 2. Then remember the square root of that. So what is my x2? It is simply 5 minus my x1 there, which is simply negative 3. So when you're replacing a negative number, enclose it in bracket. But all this stuff should be raised to the power 2 plus. What is my y2? It is 9 minus my y1, which is simply 3. Then this raised to the power 2. Remember, everything is supposed to be in the square root. So you start by working out what is in the bracket. Negative and negative will give you a positive. Therefore, it is going to be 5 plus 3 raised to the power 2 plus. What is that going to give you? 9 minus 3? Well, that is going to give you a 6 raised to the power, 2. So 5 plus 3 will give you 8 raised to the power 2. Remember, that is 6 raised to the power 2. So what will that give me? 8 raised to the power 2 is 64 plus 6 raised to the power 2 is a 36. So what is 64 plus 36? Well, that gives us 100. Remember, no calculator. This is in paper 1 of ECZ exam, so they don't require you to use a calculator. So what is the square root of 100? It is 10, and that will be units. Remember, square root means what is that number? When you multiply it 2 times, it will give you the number inside of the square root. In this case, 10 times 10 will give you 100. So the square root of 100 is simply a 10. So that is the way you can actually go about if you have been given that directed line segment. So we are also going to use, other concept that we looked at in our previous video, to apply them. For example, let me just remind you, if you, for example, you have a position vector, like I said, imagine that you have got a point A and you have got a point B. If they tell you from O to A is vector A and from O to B, that is representing vector B, and remember, this is the x or y plane. If they tell you to move from A to B, to find the vector A to B, to move from A to B, we did mention that you can start, remember I said start with this one here. It is actually always positive. So because this is a position vector starting from the origin, I can start with that. So it will be OB minus, this one here, which is going to be negative minus OA. So that's what you can do. So vector OB is vector B minus OA is simply vector B. So you remember that. Suppose they told us the other way around. I wanted to move BA. Suppose I didn't know that, but I wanted to move in that direction from B to A. Remember, it simply means A will now be positive. So BA means you move BO combined with OA. But because BO, you're moving in the opposite direction, therefore it will be negative. OA is in the direction. So